Hello everyone, and welcome to another remote sensing lecture video. And in this video, we're going to begin our discussion on something that is really foundational to the entirety of optical remote sensing. And that is the idea of electromagnetic radiation. Electromagnetic radiation. Now, hopefully, at least parts of this are a review from other science classes that you've taken. But what I want to do is I want to begin with the most basic diagram that we can make. And that is the idea that we have a straight line like this. So then we have this, and then we have this. So this is going to be an electromagnetic wave. An electromagnetic wave. And so what we have here, we have three axes. We have this axis here, this vertical axis here, and this is the electric component. I'm going to put an E there. This component here, which is coming sort of in and out of the screen, you can think of it like that. Right? This is the magnetic component. Call that M. And the axis that's going left to right here, this is the direction that the wave is moving. So this is actually distance. Actually, let's put this over here so it doesn't get in the way. All right, this is distance. And so what we can do is we can sort of think of this wave as having two components. The first is an electric component, and it looks kind of like a sine wave, if you're familiar with the sine function from mathematics. Right, it looks something like this. Right. And then perpendicular to that, let's go ahead and let's put some arrows here so we can clearly differentiate the direction that it's going. Right, it's going up and down. Something like this. Right. And then in contrast to that, coming in and out of the screen, I'm going to try and do this in this red color here. And going in and out of the screen. So let's draw some arrows doing like in and out of the screen. Not to be confused with up and down. All right, so this is electromagnetic radiation, right? We have the electric component, we have the magnetic component. And you can see that they're perpendicular to each other. So the electromagnetic waves are going, the electric component's propagating up and down, the magnetic component is propagating in and out, and both components are moving sort of along this line here in this direction. So hopefully that's a review. What I want to do is I want to now slide over a little bit, give ourselves a little bit of room, and I want to break this up. I want to redraw this again, but looking just at the electric component. So once again, right? So this is distance. Oops. distance, and this is the electric component. Electric component. And so then just to sort of redraw the graph here, right, it goes something like this. It goes up and down, up and down. So there's a couple of terms here that I want us to take away. The first term, which we'll use in blue here, is the measurement that goes from here to here. Right. This measurement from the peak of one crest to the peak of another, right, this distance here, right, this is called the wavelength. This is wavelength. And wavelength is going to be extremely important. It's actually the sort of fundamental unit for 99% of our discussions. So understanding that wavelength is this distance here is going to be extremely important going forward in remote sensing. So let's go ahead and let's write down here just the definition here. Wavelength is the distance from the peak of one crest, from the peak of one crest to the peak of the next crest. So that's wavelength. The next sort of key concept here is the idea of frequency. Right, the idea of frequency. So frequency on this diagram would be the idea that if you are standing at a fixed point, say that you were standing right here with a very accurate stopwatch, and we let this wave propagate through you, and you counted the number of times that a peak of a crest passed you by in a given amount of time, that measurement is called frequency. So frequency is the number of peaks that pass a particular point in a given period of time. In a given period of time. And then finally, right, we put this axis in here as distance, but we also have said that the wave moves along in this direction, right? So that movement is something else that we need to sort of keep track of, so that as it's moving, right? Actually, let's see if I can make that a little bit straighter. It's moving, this is the speed. Right? Is the speed at which the wave moves through space. right? So now we have three parameters, right? We have wavelength, which is the distance from one crest to the next. We have frequency, which is the number of peaks that pass a point in a given period of time. And we have the speed of the wave, which is characterized by how quickly it moves. So in the next video, what I want to do is I want to put some units to these different terms and discuss how they're related to each other. So hopefully this was mostly a review. If you have any questions, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.